record. Alright, great. So let's continue. So last time we talked about leading term and the end behavior of a polynomial, right? So when you have a polynomial and you're looking for the end behavior, then you only need to look at the leading term. Because the lower power terms compared to the leading term, this is quite small. So this dominates. Therefore, you only need to look at the leading term. For example, if x is 100, 100 to the fourth power is much bigger than 100 to the third power, right? So if you have a lot of money, a million, then do you care about a penny? Maybe not that much if you only have $1, right? So look at the dominant term is enough. Don't need to look at the lower power terms. And then keep in mind, for if n is even, then it looks like x squared, parabola, right? If n is odd, it looks like x cubed. Do you all remember parabola looks like U-shape and cube looks like that? Everybody? Yes? Okay, good. So let's continue. Example 5. So everything on this section is review. So you have learned this before in college algebra. Okay? So we're gonna go over that more quickly. So we want to sketch the graph of this polynomial, and we want to show intercepts, test points, and end behavior. So I'm gonna teach you two methods to solve this kind of problems. So method 1 is use some test points. Okay, so first of all, you still need to factor. Okay, so step 1, you want to factor. So can you see the common factor here? X. And do you realize the leading coefficient is negative? Yes? If the leading coefficient is negative, also factor out minus 1. Okay? So we factor out negative x. What's left? Wait, what's left after we factor out negative x? You mean x squared? And then? Negative. Yes. And then? Plus or minus? You factor. Yeah, minus 3. Right, everybody? Okay. So keep going. We find a common factor. Factor it out. And then here we have a quadratic term. So let's see. Minus x. Can we factor further? X squared. What did you say? Yeah, x minus 3 and x plus 1. Right, everybody? We factor completely. Then we set this equal to 0. So then just set each factor equal to 0. X equal to 0, and here x minus 3 equal to 0, or x plus 1 equal to 0. What is x? Yeah, 0, 3, and negative 1. So these are the x-intercepts, because the y-coordinate is 0. Right, everybody? So we get the x-intercept is 0, 0, 3, 0, and negative 1, 0. So x-intercept are points on the xy plane. So you need to put an ordered pair x-coordinate, y-coordinate. Okay? Alright, so this is the first step, we factor. And here you also realize, so you get the x-intercept. And usually when you want to find the y-intercept, you plug in f of 0. But because 0, 0 is already the x-intercept, so it's also going to be the y-intercept. Okay? But in general, you want to find the y-intercept, then you plug in f of 0 to find the y-intercept. But in this case, x-intercept and y-intercept 0, 0 is both of them. So we have 0, 0, 3, 0. So 3, 0 and minus 1, 0. Okay, plug these points. Put the x-intercept and the y-intercept. By the way, do you realize x-intercept we can have as many as we want, but y-intercept just one, at most one, because this is a function. Every vertical line intersects the graph at most once, right? Okay, and next we want to figure out the behavior, whether the function is above or below the x-axis. So in this case, the test point method, that's why this method is called test point. Okay, you want to find the test point on each interval. Do you see the real number line separated by -1, 0, and 3, right? So we have 1, 2, 3, 4 pieces. And each piece, you find a test point to plug in f to see whether it's positive or negative. Okay. Let's do that. Okay, so here, find a number here. What number do you pick? -2. And f of -2 is, so by the way, when you plug in -2, you can either plug in the original f or you plug in the factor form. And I would recommend you to plug in the factor form, because if you plug in here, you might need a calculator. But if you plug in the factor form, you know, like each factor is positive or negative, and you know that if you have a even number of negatives multiplied together, you get positive. If you have odd number of negatives multiplied together, you get negative. Right? You ready? So here, plug in the factor form. Okay. All right. So this is the factor form. Okay. So we have negative x is -2, right? Negative 2 become 2. Yes. And so then the next factor, -2 minus 3 is -5. And then -2 plus 1 is -2 plus 1 is -1. Oh, do you see we have two negatives that make it positive? Okay, so we know this is positive. Okay, so a function look like that. Okay, everybody, it's positive above the x-axis. All right, next one. From this piece, -1 to 0. Which point do you think? Yeah, -0.5, right? So let's put in -0.5. All right. So here, f of -0.5. What's that? Hey, by the way, you don't really need to know what number exactly it is. You just need to know whether it's positive or negative. Right, everybody? So -0.5, -0.5, you get +0.5. So to simplify, you can put plus here. Okay? And -0.5 minus 3, positive or negative? Negative. And then you put negative. -0.5 plus 1, positive or negative? Positive. See? Positive times negative times positive, you get negative. Negative below the x-axis. Is that okay, everybody? Do it faster, faster. You don't need to figure out what exactly the number is. You just need to know whether it's positive or negative. Okay, give me a number in this piece. 1. So use 1. F of 1. See? Negative 1. So negative. Right? Keep going. 1 minus 3. Negative. 1 plus 1. 2. Positive. So the answer is negative. Negative times positive. Positive. Oh, you see, it's above. Okay, so you connect those points. Finally, pick a number greater than 3. What number do you pick? 5. Oops. Okay, so pick 5. This one, what happened? Positive or negative? Negative. And then 5 minus 3? 2. So it's positive. 5 plus 1? Positive. Oh, so the answer is negative. And the graph makes sense. You know, polynomial is very smooth. So you don't want to see something like that. That's not a polynomial. Okay? You should not have a corner there. So you see, it's very smooth. Okay? So this is the graph of the function. And because the problem says find the end behavior. All right, let's see. End behavior. Do you see here? The right hand side, this end? It's going to the right. So x goes to positive or negative infinity. To the positive infinity. And it's going up or down? Down. Then y goes to negative infinity. Okay, on the left, x goes to negative infinity. Y goes to positive infinity. That's the end behavior. Right, everybody? Okay, this is method 1, which is a test point method. Now I'm going to teach you a second method. So method 1 is good when you have a simple function, not quite complicated, a lot of linear factors. And method 1 is good. But if your function is more and more complicated, I recommend you to do method 2. Alright, so this is method 2. The first step is also you need to factor. But because this problem, do you see, is already factored? Right? It's already factored. So we can set it equal to 0. And then look at so negative 5 is just a coefficient, right? And then this factor, 3x minus 1, we set it equal to 0. Or next factor, x plus 7, set it equal to 0. No, our goal is to factor. If you expand it, see? If you expand it, can you see anything from here? Does that tell you the x-intercept or y-intercept? With no clue with that. So our goal is to get the factor form. We don't want to expand it. It tells us nothing. It tells us something. If you want to find the end behavior, you just look at the leading term. But that's the only information we can tell from this expand form, right? We don't know the detail whether x-intercept, y-intercept. So you want to have the factor form. Okay, everybody? So that's why this problem is more complicated, but it's a factor form. We can start from there. Set each factor equal to 0. Solve for x. What is x? Yes, 1/3. Or x is -7. Good. So x-intercept is 1/3 0 and -7 0. So far so good, everybody? Yeah, x-intercept are points. Don't give me equation. You know this equation? It means a line. X equals 1/3 is a vertical line. Okay, it's not a point. A point is an ordered pair. X equals to number is a vertical line. How about y equals a number? Horizontal line. Exactly. Yes, good. Okay, step 2, y-intercept. So we need to plug in f of 0. Let's see, f of 0, you plug in x is 0, right, everybody? So -5, we plug in x is 0. 0 minus 1 is -1, right? So -1, but square. And 0 plus 7 is 7, and then cube. What is -1 squared? +1. Okay, I need your calculator. Could you help me to type -5 times 7 cubed? I know it's negative, but what negative what? Okay, yeah, do you have a number? What's that? Type it in your calculator. Everybody, type it in your calculator. What do you get? 5 times 7 cubed. Thank you. Yes. So this is f of 0. Then the y-intercept is, x-coordinate is 0. Y-coordinate -1715. So far so good, everybody? Now we plot the x-intercept and y-intercept on the xy plane. So x is 1/3. By the way, when you draw the picture, you don't have to do 1, 2, 3, 4. Don't do that. Make your graph clean. So your important points is 1/3. So you know 1/3 is positive, right? So you can put just here. Let's say this is 1/3. Okay, the scale don't need to be very accurate. Okay, and -7, you know -7 is negative, so you just put -7 on the left. Okay, you don't need to put a lot of power 1, 2, 3, 4, 5, 6, 7 like that. Okay, just make it simple. 1/3 here, 0 here, -7 here. Okay, so these are the x-intercepts. Oh, sorry, 0 is not intercept. Don't put a circle there. Okay, here. Y-intercept 0, -1715. See? It's a big number that's negative. But so that's why you don't put a lot of bar, then you cannot count 1,115, right? Just put another point there and say it's -1,715. Okay. We don't need the graph to be accurate. Just sketch. All right. So up to now is the same as method 1. Okay. Then 3. The third step. Instead of finding the test point of each interval, we don't do that. Okay. The method is you look at the leading coefficients. So leading coefficient, which is, in this case, the leading coefficient will be the product of all the leading coefficients of each vector. Okay? So, which is -5 times leading coefficient of this term is 3, right? The 3 you have to raise to the power 2. And here, what's the leading coefficient of this? 1 raised to the power 3. Okay. So leading coefficient is -5 times 3 squared times 1 cube. Is that okay, everybody? And you don't need to calculate what this number is. You just need to know it's positive or negative. And in this case is negative. Okay, so negative. The rule is if the leading coefficient is positive, then we start from the right upper corner. If the leading coefficient is negative, start from the right lower corner. Okay? And in our problem, the leading coefficient is negative. So you start from the right lower corner. Okay? So you can put a point here. Start from the right lower corner. Is that okay, everybody? Mm-hmm. And you connect the points. All right. So now when you get to this point, what you do is you look at the multiplicity. Okay. So if the multiplicity, what is multiplicity? So this number is 1/3, right? 1/3 corresponds to the factor 3x minus 1. And what's the power of 3x minus 1? 2. So this 2 is the multiplicity of 1/3. Okay, it's the power of the corresponding factor in the factorization. Okay. So if the multiplicity is odd, then we cross the x-axis. So you cross it. If the multiplicity is even, then we bounce off. So like that. Have you heard of this before? Good. Okay. 1/3. 1/3 corresponds to 3x minus 1. And the multiplicity is 2, which is even, right? So we cross or bounce off? Bounce off. See? We go there and then we bounce off. Alright. Good. You bounce off. And you want to cross this number too, right? So pass through this y-intercept and go back here. So far, so good, everybody? And then -7. Look at -7. It corresponds to the factor x plus 7. What's the multiplicity? 3. Odd or even? Odd. So what do? Bounce? Cross. Right? Odd. Cross. So the graph looks like this. Okay? You can also do the test point method, but if the problem gets more complicated, I would prefer method 2. Okay, so you're free to use whatever method you like. Just show all your work in the exams or quiz. Okay, so end behavior. Here, what do you say? X goes to, let's see, Dylan, what do you say? Here, X goes to infinity and Y goes to, yes. How about on the left? X goes to, and Y goes to infinity, yes. Okay, so everybody now know how to graph a function. Yes. Yeah, because the 1/3, the multiplicity is even, you bounce out. But then -7, the multiplicity is 3, it's odd, so you cross. Yes. So with this method, no matter how complicated the problem is, you can always do this way. Yeah. All right. Okay. Example 7. Expand the following log completely into an expression with a simpler log. Okay, so we use the properties of log. Okay, remember the properties of log. Log, if you have product, you can break it into sum. Right, everybody? And if you have quotient, you can break it into subtraction. Yes. And if you have some power, let's say p to the m, then you can move the power down in front. So it becomes n ln of p. By the way, ln, natural log, base is e. log, log base 10. Right, everybody? Okay. So now we want to break this. Okay, so if you have a complicated quotient, if the factor is on the numerator, then you just add it. If the factor is in the denominator, then you just subtract it. Like this. P is in the numerator, positive ln P. Q is in the denominator, negative ln Q. Is that okay, everybody? Yes. So let's do that. The 4 roots of 3x minus 5 is on top, so positive. And then the 2x plus 4 to the 7 in the denominator, so negative in front of it. Is that okay, everybody? And also the x minus 11 is in the denominator, so negative. Questions? Huh? Why not add this? Okay, you can add this, but because this whole thing in the denominator, you add this. But you get rid of the parentheses, it still becomes negative anyway. Okay? So I'm just kind of look at each factor instead of looking at the whole numerator and the whole denominator. Because if you look at the whole denominator, you need to have a parentheses in front of it. So when you distribute the parentheses, it still becomes negative. So you just look at whether the factor is in the numerator or denominator. As long as it's in the numerator, then it's plus. As long as it's in the denominator, then it's minus. You want to simplify, so you don't want the parentheses here. So that's why, yeah, this is a product, but it's in the denominator. That's why you need parentheses. You put a plus sign here. But when you distribute the parentheses, it still makes it negative. Yes. So that's why from now on, you just look at the factor. If it's on top, positive. If it's in the bottom, then negative. Okay. Good questions. Next one, we can put the exponent down in front. 4 roots. What's 4 roots? What's the exponent? 1/4. So now we can put the 1/4 in front. Okay, and here, what's the exponent? 7. So put the 7 in front. And the last factor, the last term, we don't need to do anything. Okay, so this is how to expand this log to an expression with single logs. So far, so good, everybody? Okay, that is example 7. Alright, next, we're going to solve equations involving exponential function and logarithmic function. So what do? Is first you want to isolate the exponential term. Okay, so first isolate the exponential term. In this case, the exponential term is 4 to the power of 3x minus 4. We want to isolate that. So how do we get rid of the 5 and negative 2? What do we do? Yeah, and divide at what? Yeah, very good. Add 2. Then we get 5 times 4 to the 3x minus 4 equals to what? 30. By the way, can I multiply the 5 and 4 and get 20? No, because the 5 does not have the 6. We cannot combine it, right? So now we divide it by 5. So we get 4 to the 3x minus 4. What is 30 divided by 5? 6. Yes. Okay, so we isolate the exponential term. That's the first step. And once you get it ready, you can apply ln on both sides to get rid of. So apply natural log on both sides. Okay, so natural log of 4 to the 3x minus 4 equals natural log of 6. Okay, the good thing about natural log, you can bring the power down in front. So we get 3x minus 4. Okay, what's wrong? What's wrong with this? What do I miss? Yeah, I was 6, but I still have a major mistake. What do I miss? To bring the whole thing down in front, but I need to put parentheses. This is so important. So we need a parentheses here. So parentheses is our baby. Don't forget that. Okay. You want to solve for x. So what do? Okay, let's take turns to answer my questions. Paige, what do we do? How do you solve for x? Move ln4 to the other side. So both sides divided by ln4, right? Yes. So both sides divided by ln4. Then this cancel. We get 3x minus 4 equals ln6 over ln4. Good. And next, what do we do, Mackenzie? Right. What do we do next? Solve for x. What do we do? Yeah, very good. F4. So we get 3x equals ln of 6 over ln of 4. F4. Good. Gabby, what do we do next? Divide by 3. So we get ln 6 over ln 4 plus 4 divided by 3. Yes, this is our answer. So far, so good, everybody? Yes. Okay, so 2 steps. Isolate the exponential term. Once you do that, you can apply ln on both sides. Solve for x. Okay, everybody? All right, next equations involving log. Okay, in this case, step 1. Do you see the last example? We only have one term of exponential function, right? But this equation, we have 2 terms of log. Do you see that, everybody? If you have 2 terms, combine them into a single log. So combine those 2 log into a single log. Okay, how do we do? See, this is a subtraction. If you want to combine, what's inside the log? Product or quotient? function. Yes. So this is log 8. We have x plus 5 over 3x minus 2. And that equals to 2. Is that okay, everybody? And second, how do you get rid of the log? You know, exponential function and logarithm function, they are inverse function, right, everybody? So b to the log bx, you get the x back. Or log b of b to the x, you also get the x back, right? That's why when you see the exponential function, you can apply ln on both sides. Okay. And now, if you see the log 8, both sides raised to the power. Do you see here, the base is 8? To get rid of the 8, you want to raise to the 8 to the exponent power. Okay? So both sides do a to the exponent. So a to the log a of this, right, equals 8 to the square. Both sides raised to the power of the 8. Is that okay, everybody? We want to get rid of the log 8. So raise the exponential function with base 8. So 8 to the base. This is log 8 and this is 2. So 8 squared. Good. 8 and log 8 cancel. So we have x plus 5 over 3x minus 2. What is 8 squared, Isaac? 64. Okay. So far, so good, everybody? Okay, next, how do we solve for x? Let's see, who's behind you? Is it Joseph? Yes, how do we solve for x? Yes, 3x minus 2. 3x minus 2. Don't forget your baby. So x plus 5. Can you also distribute? What is 64 times 3x? What do you get? 192x. And 64 times negative 2? Yeah, 128. Good. Okay, what do we do next? Is it Layla? What do we do next? Subtract 5? Okay, question. This is x, right? This is 192x. Do you think we should move the x to the right or we move the 192 to the left? Move the x to the right, right? So then we want to subtract x on both sides. Then the 5, you want to keep it on the left. So you want to move the 128. So you have x on one side, constant on the other side. Right, everybody? Okay. So we subtract x and we get 5 equals 191x minus 128. And we add 128 on both sides. Okay, Layla, could you tell me what is 5 plus 128? Thank you. Yes. Finally, everybody, we get x is... What's x? Yes. So this is the answer. Okay, everybody? So when you solve equations involve log, after you get the answer, you're not done. You need to check. Because log, the domain of log. Okay, so log function is like this. So the domain is from 0 to infinity. So you have to make sure your answer when you plug into the equation, all the expression makes sense. It should be linear. Okay, everybody? So that's why here you need to check. Okay, so let's see. We check, we got log 8, and this 133 over 191 plus 5 minus log 8, 3 times 133 over 191 minus 2 is 2. Okay, we want to check. Do you see this two positive number? We add them together is still positive? Yes. So this expression is good. It's okay. This one, not quite sure. Could you help me to type in your calculator? 3 times 133 and divided by 191 minus 2. Is this positive or negative? Your calculator? Plug in your calculator. Please bring your calculator to our class. Okay, yes. And tell me, what do you get? What do you get? 2.09. Did you subtract the 2?
How do you go 0 to 0?
Oh, 0.089. Thank you. So it's positive. So it's okay. This is a solution. Okay, everybody? So if you get this answer is negative, then we have no solution. Okay, everybody? Mm-hmm. What are the other equations we need to check? So, for equation involving rational expressions, then the denominator cannot be 0, right? So after you get a solution, we also need to plug in the denominator to see if it's 0, okay? And the other type of equation is the equation involving square roots. We know the things inside the square roots must be greater or equal to 0, right? So in that case, if we have a solution, we also need to plug in the expression to see if it makes sense. Okay, so for those 3 kinds, log and rational expression and square roots, we need to check. Okay, you don't just get a number and finish. No, you have to put the number back into the equation to see if the expression makes sense. Is that okay, everybody? Mm-hmm. All right. Let's continue. Okay. A function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. The graph is the set of ordered pairs x f of x, and A is set the domain of f, and then the range of f is the set of all possible values of f of x as x varies throughout the domain. So function is like a machine. You have input x and output y. The set of input is called domain. The set of output is called range. You have learned this before, right, everybody? Okay, so evaluate the following function. You see here, f of x is x squared minus 2x. Then f of 3x squared is whenever you see x in the expression, replace it by 3x squared. Okay, everybody? So that's why here, f of 3x squared. Okay, see, x squared. So we place x by 3x squared. Square. Don't forget the parentheses. And minus 2x. X is 3x squared. Yeah, you kind of erase the x and then replace by 3x squared. Okay, but don't forget the parentheses. The parentheses is our baby. Everybody say parentheses. Parentheses. Hey, everybody say parentheses. Yes. Okay, let's simplify. What is 3 squared? 9. And x to the 4. 2 times 3 is 6x squared. Yes, very good. All right. We also have f of p minus 4. And that is, see, x. Replace x by p minus 4 square, right? Yeah, replace x by p minus 4. But don't forget your parentheses. Minus 2 times p minus 4. Also, don't forget your parentheses. Here you can leave it like that. You don't need to expand it. Just leave it like that. Okay, everybody? All right. That is example 9. Okay, example 10. Find the domain and range of the don't find the range, just find the domain. Okay, range is too hard. Write your answer using interval notation. Okay, let's do that. So 3 functions with restricted domain. So 3 functions with restricted domain. First one is square root. If you see square root, you need the things inside the square root to be greater or equal to 0. Yes? What's the graph of square root? Anyone else? Start at the origin and go up or yeah, yes. So this is square root. See, the domain is greater or equal to 0, right? Second one, if you see fraction, what do you say about the denominator? The denominator of a fraction cannot be 0. So 8 cannot be 0. Do we have any restriction on the numerator? No, it could be anything, right? Okay, and the third one is the log. Okay, let me just talk about the log. What do we need? The things inside the log to be positive, right? Positive. See the graph. It must be positive. So this is the 3 function with restricted domain. Now, of course, we have more trig functions like tangent. Remember the graph of tangent? Yeah. So we'll talk about those later. And tangent, cotangent, secant, cosecant. You have the domain x cannot be some numbers. We'll talk about that next week when we review the trig. Okay, now let's look at each expression. Do you see this is a log? Right? So the things inside the log, which is 5x minus 3, need to be positive. Yes, everybody? And the next expression, do you see this is a fraction? What do you need? The denominator cannot be 0. Right, everyone? So here we need x minus 7, 4x plus 7, not equal to 0. And we want to solve for x. Okay, on the left, how do we solve for x? We F3, right? And then divided by 5. By the way, when you work with inequality, multiply or divide by a positive number, it won't change the inequality. But if you multiply or divide it by a negative number, what happens? Flip the inequality, right, everybody? Second one, x minus 7 and 4x plus 1 not equal to 0. Then you set each of the factor cannot be 0. So x cannot be 7 and yes, very good. Let's draw it. real number line. X greater than, greater than, do you see, do we include the endpoints? 3/5. Greater than, it's not greater or equal, so we don't include the endpoints. Greater than is to the left or to the right? Right. And 7 is bigger than that. Not equal to 7. Put an open circle there. Where is negative 1/4? On the left, right? Not equal to negative 1/4. Do you see what the region? This, right? Okay, use interval notation. So if we start from 3/5, do we include the endpoints? No. To 7, do we include the endpoint? No. Union 7 to infinity. Okay. So this is how we solve this kind of problem. Sorry, 1 minute late. Okay, so we will continue on Monday. Have a nice weekend. And please print out the notes for next week, okay? Yeah. You need to print them out from the rest of the semester. So I would recommend you to print out all of them so that you don't need to write out. Thank you. Print it out like every week. Okay. Oh, awesome. Oh, could you also put your phone number here? Thank you. Yeah, print them all out and you can put it on a binder. Then every week you just grab one. So you don't have to worry about printing it again every week. Okay. Bye. Thank you. Ah, I think so. Let me see.
Oh, yeah,
Yes, yes, you did. Good.
And also, where's the room where I can print everything? Is it on this
Oh, the room. Oh, okay. So, yes, library. Let me show you.